Hello guys, in order to celebrate the 50th anniversary of Pong, we are going to build it from scratch in Unity. Pong, created in 1972, was one of the first video games ever. Creating the game is fairly easy compared to nowadays games. So this is also an excellent way to get started creating 2D games in Unity. Let's start by creating a new project. We're going to create a 2D project. We're going to use URP and we're going to call it Pong. So here we are at the Unity editor, and let's first create a few objects. We're going to create a circle. This is going to be our ball. Let's scale it down a little bit. Make sure the X and Y scale are the same, so it's a perfect circle. And now we're going to add a square, something like this. And this is going to be our bed. We're going to have one at the left side. I'm going to press Ctrl C, Ctrl V to create a copy and put one over here as well. The human player will be on this side. So let's call this the player. And the other one is going to be the opponent. It's going to be a computer player. So let's call him bot. And we're also going to give a name to the ball. Now if we play the game, nothing will happen yet. Everything's static. So we need to write some scripts to make things happen. But first let's go to the camera and change the background to black. Now we're going to create a first script. We're going to put it on the ball. I've created this folder called scripts, and over here I'm going to create my first script called ball. Let's open it with Visual Studio. We are going to change the default code to this. You can type it in yourself or download it from my repository. I'll explain the code for you step by step. First we got this constant, the ball speed. That's the speed that the ball has, but it doesn't tell us anything about the direction the ball is moving in. So therefore we have this factor 2 speed that indicates the speed in both the Y and the X direction. At the beginning, when the script is first used, we will initialize the ball and set it to a certain direction, the speed to a certain direction. And then in the update function, we will change the position of the ball by using the speed in the X and Y direction. We also multiply by time delta time in order to compensate for faster systems. On a fast PC, this update function will be called many times more, and that would result in a much faster moving ball. So therefore, when we use this, the ball will move the same speed on any device. You could also realize that by using fixed update. In that case you wouldn't need this part, but if you do so, you miss out on the opportunity to call this function many times and have a more precise movement. Another thing I need to explain is the angle the ball is moving in. The speed consists of two components, the X and the Y component, and by using an angle and using the sine and cosine multiplied by the ball speed, we always have the same speed, but it consists of two components. The angle that we're using is this red part. If you take an angle, it's 360 degrees. That's 2 radians, 2 pi radians, because we're using radians on the script. So you don't want to shoot the ball precisely in the X direction or the Y direction, because then the ball will just move back and forth and never move to another position. So we want to shoot it somewhere between those angles. So I chose this part, so the ball will always move first to this player and then he needs to bounce the ball to the other player. So therefore we have this small value, and then we have a value smaller than a half a pi, because pi times a half would yield in this exactly, because remember a circle is 2 pi radians, so this is half pi, this is 1 pi, this is 1.5 pi, and this is 2 pi or 0. So now let's add the ball script to the ball and run the game. We see that the ball is moving, but it's just disappearing from the screen. If it hits the upper or lower edge of the screen, we want the ball to bounce back. So let's write the code for that. So here's the script again with extra code to make the ball bounce. To make the ball bounce, we need to know the edges of the screen. We can do that like so on a 2D game. And then we are checking if we hit the bottom or the top. And if we do so, we invert the speed in the y direction. We also move another step so that we don't meet this condition again and bounce back and forth all the time. And we've added this part just to make the ball also bounce on the right of the screen, so that we can work on fixing the player his paddle. So if we run the game again, you will see that the ball is bouncing on the upper, lower and the right side of the screen. But the next thing that we want to do is make this paddle move, so the player can actually try to stop the ball. And therefore we're going to create a new script. Let's call it player. And let's immediately attach this to the paddle. But we not only need this script, we're also gonna need player input. So we're gonna add a package. Just go to the package manager, to the Unity registry, and search for the input package. I've already installed it, but you need to press install button over here and then restart the Unity editor. Unfortunately, this input package is still not by default added to your project. So once you've done that, you can create a folder called input, and inside this folder we're going to create input actions. Let's call it player inputs or something. It doesn't really matter that much. And then we're going to define a new action map and a new action. We're going to call this action up, so this will make the paddle move up, and to do so we are going to use a binding. You can use multiple bindings, but let's choose just one, and it's going to be the up arrow of the keyboard. And then we're going to add another action. This is going to be the down action, and it's going to be bound to the down key. You can choose for a button or a value type. Button is things that you click only once, but these up and down keys, you keep them pressed for a long time and then you release them. So the releasing is also important. So therefore we are using a value instead of a button. So put them both to value, and then save or hit autosave. Now we got our input mappings, and we can go to our pedal, the player pedal, and add a component, player input, and we're going to use the action map that we just created. So now our script is able to read responses from the keyboard. Our player script will look like this. We got this on up and on down function. These are called automatically when the up key or down key is pressed, because we've mapped the player inputs to this pedal, and this name, exactly this name, will be called once the up key and down key is pressed. So for example, when the up key is pressed down, we will receive this value and we will store it to indicate that the up key is currently pressed. And once it's released, this function is called again, and we can update it and say that the up key is no longer pressed. So at all times we know if the up key or down key is pressed. Then in the update function, we are going to make the pedal move up or down when the up or down key is pressed. We also set some limits so the pedal doesn't run out of this screen. Okay, it works, but we are not able to stop the ball yet. Therefore, we need to use collision detection. In order to have collision detection, we need to add colliders. So we're gonna add a box collider 2D to both pedals. And we're gonna add a circle collider to the ball. We're also gonna add a rigid body to the ball. This makes the physics system work. But we're gonna set the gravity scale to 0 so the ball doesn't drop down like this. Next, we modified the code of the player script to this. We're gonna add a reference to the ball because we want to change its speed. Then we have this onCollisionEnter2D function that will be called by Unity as soon as the pedal collides with something. In this case, it will collide with the ball. We could, by the way, also use the ball, his onCollisionEnter, to handle things, but we will do it on the bed instead. Then we will check for the player speed. If it's less than 0, so if the ball is moving towards us, then we will bounce it back. That will prevent any glitches from when the ball is just deep enough into the pedal that it will bounce back and forth all the time. So we need to make this to expose this speed. You can do it like that. So now we can call this speed. We can change the values. So over here we change the x value of the speed to minus the x value, so that the speed will move in the different direction. Because we added the reference to the ball in the script, we also need to set it. So there is only one ball script in the scene, so we selected that one. And now if we run the game again, we should be able to bounce the ball off the pedal. Yes, you can see that it's working. So If we hit the ball, it will bounce to the opposite direction. So that's good, but now we need the opponent to do something. So therefore we're going to create the third script. Let's call this script bot, because it's the bot that we want to move around. And let's immediately add the bot script to the pedal and open it. The bot script's gonna look like this. We also got the onCollision function, just like the other pedal, but it's a bit different. If you compare them, I can show you. In this case, we're checking if the value is less than 0. In this case, we're checking if the value is greater than 0. Because we want to bounce the ball of this side only when it hits us from this direction. Okay, so and then the movement of the bot, he will just follow the position of the ball, the Y position. So if the ball is moving up, the pedal of the bot will also move up, but it will do so at a slower speed than the our player has. So it's a speed of 5, and you can see that our player has a speed of 10. So the bot is not that fast and sometimes misses the ball, and so then you can score a point. You can make the game harder by increasing this value, but at a certain point this bot will respond so fast that it will bounce every ball back and you don't have any chance of winning. So we also need to set the ball reference to the second pedal. And now if we run the game again, you'll see that the bot is responding and actually just scored a point. We also want to keep track of the score. So let's create some UI over here. Let's create a Text Mesh Pro, which will automatically also create a canvas for us. And let's create, let's call this text score. Set it to 0, 0. And we need to import Text Mesh Pro Essentials, and we'll also import the examples. So we'll have some fonts that we can use in the UI of our game. So if you take a look at that score, it's now in the bottom left corner. We will move it to the top, and we will also make sure that it sticks to the top. We're gonna set it to auto size. Make sure it can become very large, something like this. You can fine tune this a little bit. And also set the scale mode so that it scales with the screen size. So you can see that this score is scaling with the size of the screen, so it will look good in any device. It will stay in the center top of the screen. We could save this score in this player script, but we will create a fourth script called game, where we will keep track of this game statistics and also do some management on the game. The game script is gonna look like this. We got a reference to the UI score text, and we also store the score in 2 integer values for both players, and we have an indication if we are playing the game. If you have a large game, you'll probably have a lot of game states, but this small game has only two situations. We are either playing the game or we are waiting to play the next round. So therefore we use this boolean value. Then we got this onStart method that will be called by pressing a key. So it's not the start method, but the onStart that's been controlled by an input. And then we have that method to increase the score of either one of the players. And when the score is changing, we're also setting the score text. In order to use the game script, we're going to create an empty object over here called scripts, and inside that we're going to place another game object called game. So this is for the game script. It's just a placeholder, so we can add the game script over here. We have that reference to the score text, so we can set that. And we also need to add the input component. We can use the same action map, but we need to add a key to it, the start key. And to the start key we will bind the space bar. And let's also bind the enter on the keyboard. So now if we press the space bar, this code is executed and the playing game boolean is changing to true. So if we are not playing the game, then we will not move the ball. So that's our way to just pause the ball and have that state where we are waiting to play the next game. So very simple. In the update method of the ball, if we are not playing the game, we also need a reference to that game script, by the way. And we also need to expose that this one we already did. So if we're not playing the game, we will just return immediately in the update function of the ball, so the ball won't move as long as we're not playing the game. To detect whether we need to increase the score, we're gonna change this bouncing of the right side, and we're also gonna add detection for the left side. So if we go past the left side of the screen, we will increase the score of the bot, and if we are past the right side of the screen, we will increase the score of the player. We will also set the playing game to false, so we need to press the key again, the space bar, to start the next round, and we're going to initialize the ball. In this initialize function, I've added a reset of the position of the ball to the center by using the vector 0. Because we added a reference to the game script, we also need to set it. Again, there is only one game script in the scene, it's over here. So we add that to the ball, and then we can check out if it works. Okay, it works. I need to press the space bar, and then as soon as the ball is past the one of the edges of the screen, the other player scores a point. So there is only one thing that I want to add to the game, because now you can see that the ball is bouncing back and forth always under the same angle, and that's kind of tedious. For example, in this situation, the ball is moving under a very easy angle, and both players can easily return the ball. So what we will do is, as soon as you move the pedal while the ball hits it, then the ball will go into a bit of a different direction. That's also what happens when you naturally hit a ball with a pedal and you move it in the same time. So let's implement that. For this final part, we will create another script. We will call it speed indicator. And it will calculate the speed of the object for us. The code looks like this. We're just storing the position, the Y position of the transform that this script is connected to, and we store it in the previous Y position variable, and the current speed is the current position minus the previous position. So that's the speed at which the object is moving at that moment. Now we can attach this script to both pedals. So this pedal has the bot script, has the player script, but it will also have the speed indicator script. And this bot has the bot script, but also the speed indicator script. And now we can call that script to check the speed of those objects. Now we're going to add an on-collision enter to the ball as well. And as soon as the ball collides with something, this will always be a pedal. Then we are obtaining the speed indicator object from the pedal. So this value is actually never null, but we have this check for safety anyway. And then we do something a little bit complicated. We check if the Y speed of the speed indicator is larger than 0. In that case, we will increase the ball speed by 15% of the maximum speed. We will also check if the speed isn't higher than almost the limit of the ball speed, because that would mean that the speed the ball is moving too fast. And if it's exactly the ball speed, the ball will be moving completely vertically. That's also something that we never want to have, because then the ball won't reach any of the left or the right sides of the screen anymore. So therefore we have this small subtraction over here. So the same goes for the opposite direction. So then we have this Y speed a little bit increased, depending on whether the bat has a certain speed at that point. Then we need to calculate the X speed. We can do that by the formula, the well-known formula a squared plus b squared equals c squared. So if we turn them around a little bit, you get this. And so we can calculate what the X speed will be if we want to have a ball speed like this. Finally, this calculation is always positive, because we use the absolute value over here, because we can't have a square root of a negative value. So then we need to check the X value again. If it was larger than 0, then this was meant to be positive, otherwise it's meant to be negative. Okay, that last part was a bit complicated, but I can show you the effect it had. If we move the pad while hitting the ball, you can see that it moves in a different direction than it used to do before. So it's not just reverting the X speed, but also changing the Y speed. That makes it much more interesting movements. You see that if we scale this screen, the pedals are moving, and we want them actually to stick to the edges of the screen, to the left and the right side. In order to do so, we can add this code to the player and this code to the bot script. And now you can see if we scale the application, the left and right pedal stick perfectly to the left and right side of the screen. That's it. We got a working version of the legendary Pong in Unity. You can extend this game in many ways. So have fun and see you in the next video.